this. So you must have need to remember L is equal to lambda x and m is equal to lambda y. Basically one book is using lambda x, one book is using L, so you don't need to confuse. You must remember this point, so you have a concept automatically when you are seeing in any type of book. So this is our equation, and how we can apply on this member. So we know that this truss has 6 members, so our first member is this. So we are taking member 1, its length is 2 and its L lambda, which is lambda x, is equal to x2 minus x1 divided by L, which equation we know that we have discussed previously. So x2, what is x2? Member 1 first point is x1, member 2 second point is x2, this point. So x2 is 2 and x1 is 0, so 2 minus 0 and divided by L, 2, so 1. And same as this y, lambda y is m, it's a vertical distance. Its member has no vertical distance at this point, and same as this for this point. So these are both are 0. 0 minus 0 divided by L, L is 2, so it's 0. So you have need to remember one point: before you are putting these values in it, this value divided by L. How? Why? Because this equation is AE divided by L, so you are dividing initially by L, so don't make more difficult for yourself. So direct divided by L, so 1 divided by L before putting its L square. L is here, this is L, so L square 1 square and divided by L. L is 2, 1 divided by 2, 0.5. okay, so same as this is LM, you are multiplying 0, so it is 0. Same as it is L square, 1 square 1 divided by L, which is 2, and it's minus sign, so 0.5. Same as it is this equation we are applying at here. So now this is our K1 we get, and here is the detail 1, 2, 3 and 4, 5, say all members detail. This is member detail 1, and same as it is, this is 2, this is 3, this is 4, this is 5 and this is 6. Its directions are given. So now we are taking member 2, which is this inclined member. Inclined member length we are calculating by Pythagoras theorem. We know this 2, so this is our inclined member. We know its base and its height, which is 2, and base is also 2, so we're using Pythagoras theorem. We can find 2 square plus 2 square over whole under root, which is come 2 under root 2. So we get our this member x distance as x2, same as it is 2, and this is our x1, so 2 minus 0 and divided by L, which is this member length. Okay, so this is 2 under root 2, and this equation is come. So now we are finding our m, which is lambda y. Lambda y is starting from 0 vertical distance, which is first point, and this is our second point, which is 2. So y2 minus y1, 2 minus 0, and same as till length, and we get it here. We know that we are putting value at here by dividing by L. So this is L square, we know that this is L square, so L is this, we can take this square and divide it by this L, so we get 0.17. After that we can LM, multiply this one to this one and divide it by L, so we get this equation. So this is same sequence which we get from k1, and this is same for k2, and this is as it is same for k3, and just difference of inclined member, which is by using Pythagoras theorem. Just length is same. So now this is for 5. So now after the finding of 6k values, 6 member k values, now we just have need to find this and make this 8 by 8 equation. How we can find? It's looking difficult, but it's not. It's very easy. Just trust on me and follow my instruction. Okay, you have just see 1 and 1, first column and first row. Just go to your all 6 values where 1 and 1 row and 1 column matches. You just have need to take value, and if they are multiple then add them and put at this general equation. So 0.671 and 1 and 1, so we are going 1 and 1, 0.5, 1 and 1, 0.175, add them, and where is 0, so just add these two values, these one 0.176 and 0.5, so we get 0.676, we get this. Okay, so this is 2 and 1, we just have need to go 2 and 1, this is 0, 2 and 1, 2 and 1. Okay, same as this 2 and 1, 0, just put it here, same as to this value, same as this go 3 and 1, 4 and 1. For example, randomly we can see how this value come. Okay, this is 4 and 5, 4 and 5, 4 and 5, 4 and 5, this one 4 and 5, 4 and there is no 5, okay, leave them, 4 and 5, 4 and 5, so there is only one 4 and 5, 0 minus 0 minus, so this come. If we see how this 8 and 8 come, we just have 8 and 8, 8 and 8, 0.5, the other 8 and 8, 0, so there is 1, so other 8 and 8 is at here, yes, this one, so just add them and put it here. Okay, so this is very simple. Okay, so basically in this question I gonna go about the k1 and k2 value. This is our next example in which we are seeing clearly. So we know that how we can find k1 and k2. In this question I am directly solve, and by the just make our table and find to make easy for ourselves. So basically this is equation, and one by one we divide member just like previous one. So we make k1 value, k2, and same as this k3. So now I can tell you about how you can make the combination of these three case values. This is the combination of 3 case value. How they come? So initially we see 1 and 1, so you have need to see first column and first row. So here in these 3 terms, where is the 1 and 1 matches, you can add all these 1 values. For example, k1, 1 and 1, so here is matches where 1 matches at here and this one matches at here, so 0.432. in k2 value 1 is this and 1 is this, so this is 0.432. you can add this 432 and this 432, so when you add these two, so in this matrix no 1 1, so you can add both them, so 0.864 comes. Now you need to see 2 and 1. So you can see 2 and 1, 0.576 in this 2 and 1, 0.576. Both are same value but opposite sign, so cancel each other. So here is come 0 0. Same as it is 3 and 1. You can say 3 and 1. Same as it is 3 and 1. Sorry, 3. It's only 1 at here. 3 and 1 minus 0.432. So yeah, here is same as it is. You can match this column number and this row number and see where is this column and row. So if these come 2 in k1 k2, so you can add, otherwise you can simply put at this equation. So you make 6 by 6 equation. So after that you just have need to put this equation. How we can put this equation accordingly? We know that these all are forces which is denoted by W. These are forces, these are K value, which is this, and this is delta. So basically we this is whole equation is this part we are finding separately, but now we are put this equation at here in. So we put this equation at here, and this is our forces, and this is delta, which is our deflection. So we now two forces, this two forces 1.2 and 11.5, 2 and 1. So we can put it here 11.5 and W2. So we know only 2, so we can cut just 2 rows. Okay, 2 rows cut and 2 columns cut are denoted by this line, dotted line. So this is our cutting portion. We know W1 W2, W1 W2 all values we are know. Okay, so just we multiply each other and find this. This is inverse, so we take inverse. Inverse mean divided this by 1. 1 divided by 0.84, same as it is 1 divided by, so this come. So we take inverse and multiply, and this equation come. We know now we know that delta 1 and delta 2 value, this delta 1 and delta 2, or W1 W2. So remaining this portion required, W1 W2 we know, W3 W4 and W5 6 we can take it here. So this is all taken from this value, and same as it is 13 and delta 1 and W2. By the reference of delta 1 and 2 we can find remaining forces. So basically these forces are 0. How? Because we know only these two, so we can put this delta temporarily 0, and by the reference of these two, and we can find this one. So we just have need to multiply, and the all forces we know, 6 forces we know, so we just have need to put at here. We in question we have just given these 2 forces, so by the reference of these forces and direct stiffness method we solve and find remaining support reactions. Okay, export, y support, export, y support. By the these inclined forces we use simply this equation. This is very simple, but I have tell you the difficult thing, which is that here. These are the simple thing. We just need to put values and find inclined forces member. Okay, thank you.